Welcome back. We are doing part 2 of this question, part B. The last video we watched is, or the last video we completed, I should say, is us calculating these two numbers right here. So we have the value of the number of steps that occur in this if statement here, lines 5 to 9. We have the number of steps that occur in the lines 5 and then 11 to 17. And now we're going to look at doing the rest of this. All right, so let's calculate the number of steps overall. So let's start with, I guess we'll do like blue. We have our while loop right here. Oh, that's pretty thick. Hold on. While loop. We have these two lines that we definitely know we need to consider. But now we have to ask ourselves, how are we actually going to do this? Because we know we're not going to go into both this if and this else. That's just not possible. So instead, we're going to ask ourselves, what actually is possible to give us our worst case scenario? And so what we'll do is we will look at these two values here, this one, and we'll determine which one is technically more steps because we're looking for the worst case. So really, without actually doing any of the proof, if you were to do the proof, you could pick some values of n, and you could mathematically prove that this is the case, that this is going to be the slower of the two algorithms. It's going to be the slower option. And since we're calculating worst case, we do want to use the slower option. Now, we do want to make sure that we ask ourselves, is it possible for this to occur every single time, such that this worst case will then be accurate? And the answer is, of course, yes for this one, because the way we get into the else is if our two arrays are different from each other, and there are no preconditions or special limitations that tell us that that isn't acceptable. So we can now recognize that the lines that we need to consider as part of this final calculation will be those lines. Oh, and this line. That was really big. Boop. Okay. So we can see that the lines that we haven't yet calculated include the ones that are highlighted in blue and pink. 1, 2, oops, and 3. So let's start with the ones in blue. Let's finish off that while loop, and then we'll do the ones in pink after. So we know that this is going to add +1. This line 18. We know line 4 is going to add a +1. We can't forget about when that's false. That'll give us one more +1. So in one iteration of lines 4 to 18, we're going to get 1 from line 4 plus the inside worst case scenario plus another 1. And now we're going to ask ourselves, I'm going to put this 1 over here. This is my false one so that I don't forget. I'm going to do this, and we'll say 3n squared plus 11n over 2, over 2 plus 5. And we're going to ask ourselves, what is that summation? Well, let's take a look. Here we start with k, and k is equal to 0 up there on line 3. So we're going to say k equal to 0. And then we need to see that we're going up to, but not including n. So we're going to go to n minus 1. And now we have this formula that we can walk through. So the first thing we're going to need to do is separate out our n squared and our n terms just to make our life a little bit simpler for handling that situation. So let's go ahead and rewrite this. Let's get this going like this, from 0 to n minus 1 of 3n squared over 2. Let's get another one going, over here. K equals 0, n minus 1, 11n over 2. And then one more at the end for k equals 0, n minus 1 over 5. So we have our 3 terms now nicely separated out. We're going to go ahead and start factoring stuff out. How do we factor out of these ones? Well, just a quick reminder that if we were going over the counter variable, then we wouldn't want to factor it out. But since we're not going over the counter variable, we're going over the total variable, meaning this is already defined outside, like that n is defined outside of the summation. We can actually pull that whole heckin' thing out. So let's do that. Let's do 1 plus 3n squared over 2 with 0 to n minus 1 of 1. Let's pull out that 11n over 2 and do the exact same thing. And then we can pull out that 5 as usual. K equals 0 and minus 1. And now we can just do our calculation. So as we know, this is going to be n, this is going to be n, and this is going to be n. I'm not going to do those calculations right now because we've seen them lots of times at this point. We'll do this. We will go ahead and do the next one. And we'll do the last one. Now we can go ahead and rewrite this with all that information in there. 3n cubed, now it's cubed, over 2 plus 11n squared over 2 plus 5n plus 1. And if we scroll back up, we have to remind ourselves that there was 3 lines of code right here that we also have to consider when working toward our final answer. So and a plus 3 from those 3 lines. That's going to give us a worst case number of steps for the function above to be 3n squared over 2 plus 11n. Oh, why do I keep putting a squared there instead of a cube? Slowly killing me there. All right. 11n squared over 2, 5n plus 4. And again, that's our worst case. And just a final reminder on why we're doing that. It's worst case because our data really depends. It really will change sort of what our 2 scenarios are. If we were trying to consider the best case, it means we would always go into here. The worst case is we always go into here. And if we want to get something a little bit more average, we'd have to take the average case, which would be probably half of our numbers are going to end up going over here. Half of our numbers are going to end up going over here. And then, of course, we can see how this might get more complicated in those scenarios. As computer scientists, we often care about the worst case the most, but we will definitely see the other cases as well as we move into the next unit. So thanks, everyone, for joining me for this counting steps video, and I'll see you in the next one. Bye.